Problem 17 is asking you to find which of the following series are convergent. So the first series I have written up here, I have negative 1 to the n times e to the 1 over n. So to prove if that's convergent or divergent, there's a couple different things we can do. First thing I do notice is that it is an alternating series. So if we just go ahead and try to apply alternating series test, that should tell us. So if I go ahead and apply alternating series tests, remember AST, the first thing that it has to satisfy is that the limit of b sub n as n approaches infinity has to be equal to 0. So in this case, my b sub n is e to the 1 over n. If I take the limit of that as n approaches infinity, do I get 0? Well, if I plug in infinity, 1 over infinity is equal to 0, but e to the 0 is 1, because anything to a 0 power is always 1. 1 is not equal to 0. Therefore, this doesn't pass the alternating series test. However, there's a rule that says that if it fails this first series test for alternating series test, it's actually divergent. And it's actually divergent by test for divergence, because the limit itself is not going to 0. And remember, test for divergence says that the limit is not going to 0, then it should be divergent automatically. So, therefore, this first series is divergent. Next series is n equals 5 to infinity of negative 1 to the n, and I have n over 5n plus 1. So if I have an alternating series, so I can apply an alternating series test to it again and see if that works out. So when I apply the limit of this, as n approaches infinity, of b sub n, I have n over 5n plus 1. If I look at the limit of this as n approaches infinity, it's indeterminate, so again, I can apply L'Hopital's rule to figure it out. This ends up coming down to 1/5. Again, 1/5 is not equal to 0, so therefore this series is divergent by test for divergence, because it came out to something other than 0. So I have 2 divergents so far. Now, if I look at my answers, I probably could narrow it down. I could figure out that answer actually should be C, because there's nothing in there that says that none of them could be convergent, and 3 only is the only one left. So that one must be convergent. But let's see if we can prove it somehow. So if I actually write out the series, I have summation n equals 5 to infinity of natural log of n to the 12th power over n to the 9 over 8. So I need to figure out if this series is convergent or divergent. And the best way for me to do that would probably be to do some kind of comparison test to it. So in this case, what I'm actually going to compare it to is I think I'm going to do a direct comparison in this case. So remember, a direct comparison says that 0 has to be less than or equal to a sub n, has to be less than or equal to b sub n. And if I want this to be convergent, which in this case I know it should be convergent because the answers, if this isn't convergent, that doesn't make any sense. We probably did something wrong somewhere. So if this needs to be convergent, b sub n, the series that I'm comparing it to, needs to be convergent for this, my a sub n, to be convergent. So the way I'm going to write this out, I'm going to say that natural log of n to the 12th over n to the 9 over 8 has to be less than or equal to some series that I need to know is convergent. So in this case, what I'm going to do, I'm going to compare it to, I need something that's going to be bigger. So if it has the same denominator, let's say I want to keep that denominator in this case. I want to keep n to the 9 over 8. So that means that whatever is on top has to be larger, because as long as whatever's on top is larger than this, should always work out for an inequality. So what I could pick is I could easily pick n, so this is to a 12th power, and I know that n to any power should always grow faster than natural log to that power. So if I have n, I could write it as n to the 1 over 12. Now knowing this, I can figure out whether or not this is going to be convergent or not. So I basically just need to figure out if 9/8 minus 1/12 is still greater than 1. Because if it is, it passes p-series and it's convergent. So 9 over 8 minus 1 over 12, let's see, so that would have to be equal to 9, 12 times 8, and then I would need a 12 up here, minus 8 over 12 times 8. So 12 times 9, that would be 108. So 108 minus 8 is 100 over 12 times 8. That number should still be greater than 1, because 12 times 8 is 96. So 100 over 96 is still greater than 1. This is still greater than 1, therefore this power is still greater than 1. So I have n to the 100 over 96, which is greater than 1. So therefore this is convergent by p-series. Because this is convergent by direct comparison test, DCT. So that one was convergent. So that shows that our final answer, letter C, is in fact correct. 3 is the only series in there that is actually convergent.
The Teaching Center, UF's Learning Resource Center.